ahead again to ask questions or stand in line at the microphone later. Are you ready, Dietmar? Then the floor is yours.
Not yet. Yep, all good. Yeah, good afternoon, everyone. Now something completely different. This is a talk about our research methodology, and I would first like us to look at what do our papers look like, the papers that we publish. Like most of the papers, we have like a novel machine learning model somewhere that predicts some actions, preferences, and the papers then provide in the second part some empirical evidence that this model substantially advances the state of the art. So, and for number one, there are some requirements. There has to be some technical novelty, and you should have some certain level of sophistication from the technical perspective. And for number two, you have to show that ours, which is the new model, is better than the rest, the state of the art. And in the best case, on all accuracy measures you take, all other measures you take, on all data sets compared to all baselines. So the problem is that what's the state of the art? So I would say the problem is there is no unique set state of the art that you can compare with, in the sense the state of the art is a small set of models that is better than all the models on all data sets, on all metrics, because we know that the performance of an algorithm depends on many factors like data set characteristics, pre-processing choices, accuracy metrics, and so on. So now let's assume we don't have that state of the art. How can we do research? We make some assumptions. So we provide experimental evidence for a few baselines that we include, recent ones. We use common data sets and common metrics. And sort of let's convince the reviewers in some, that's a bit negative phrasing, but you know. So, and researchers in that context have some freedom how they do their experimental design in terms of data sets and baselines and metrics. And as we will see later on, this in its own has some issues in terms of the methodology. But let us first put this aside. Let's assume there is this agreed upon state of the art, and researchers really try to come up in good faith with some configuration to show that they advance the field. The question is, what's a fair and, importantly, an insightful comparison? And I think we all can agree that if we compare models, we can only conclude anything from this if we optimize each of the models as good as it gets on all data sets and all metrics. So to be fair, just we tune all the models thoroughly. That is the only way we can have any insight. Otherwise, we would compare optimized models versus non-optimized ones. So and the typical step here is hyperparameter tuning. So we have all sorts of things that we can tune which impact the performance, embedding sizes, learning rates, and so on. And we all have the technology to do this in an automated way for the data sets that we examine. Now, an interesting observation is, in terms of hyperparameter tuning, what is reported in papers is usually a lot of details about what was done for the method called hours, like the ranges that were examined, the tuning method, like grid search, and in the end, the best hyperparameters, in the best case for all the data sets that we have. But when we look at what is reported for the baselines, right, there's detailed information about what was done to tune the process, the best values. This is always almost missing, right? Or there's some vague statements provided that we did some effort to do something. And this is some intuition that we had, and then we scanned recent conference proceedings, including events that we consider high quality, KDD, SIG-RR, and so on. And we found 21 relevant papers that do top-end recommendation, and we looked at what is documented, right? We're not making any claims what researchers did, if they tuned baselines or not. We just look at what is documented in the papers. We cannot know what is done, and there's a disclaimer. If we look at our own research, we made the same, exhibited same patterns of shallow reporting and maybe of limited tuning, to be honest. So this is what we found, and let's look at some example. Here's one, and we're not mentioning explicit papers here. The list of examined papers is in the online material. Everybody can check for their own. So there's one example that they reported the search ranges for the typical hyperparameters like learning rates, and then for the method-specific hyperparameters for some of the baselines, they just said we took the parameters from the original papers, like some weighting factors. In the end, in this paper, the optimal values are not reported. So we're not really sure how they ended up with the numbers that are reported in the paper. And then we found in this particular paper, there's some URL provided, but the GitHub repository is empty 1 year after the conference has happened. Another somewhat positive example, they report hyperparameter ranges and some chosen values for all the baselines, but they don't inform us how they tuned, how they come up with the values. Did they search manually? Was it done systematically? And so on. And interestingly, in this still positive example, there's only one set of hyperparameter values. And I think if you look at such papers, algorithm papers, there's one best value configuration reported, even though we have 3 different data sets, which is very strange in some way, right? And in some, if you look at that, only 2 of the 21 reported of these papers, they report things in quite some details, like the ranges to search for, the chosen values for both the proposed model and the baselines. And another one here points to an empty GitHub repository, which is also not unusual, I would say. So, but if we look back now what we said 3 slides before, now assuming that the tuning wasn't actually done, or at least it's not reported, we remember for any comparison that makes any sense, we have to tune all the models on all data sets individually. Otherwise, we can conclude nothing in reality, right? And we know, we did some studies. This is a huge computational effort. The newest deep learning models, in particular the graph-based ones, they're very difficult to tune. It takes lots of resources, taking weeks. And still, surprisingly, in all these papers, after weeks of effort, not a single word is spent on how we tuned the baselines, right? And again, disclaimer, including our own work, right? It's not to finger point to anyone. It's about our methodology in the community. Now, looking at the papers, we found other dark patterns, as I say, in the tuning process. There are many, many papers that said, in the comparison, we use the same item or user embedding size for all the models for fair comparison, which in fact is a very unfair comparison because the embedding size is a crucial hyperparameter that significantly impacts the performance of all the models. In terms of reproducibility, we found that 50% of papers provide code, at least, but not a single one. Not one repository included the baseline code. So the researchers must have implemented that, must have made the measurement, they must have tuned it, but still they're unable to share. And another final pattern here is a number of GitHub repositories did provide the training code, but they never show the script that produces the numbers reported in the paper, right? That's another bad practice we observed. So now if we assume that the researcher actually did not tune the baselines, which we cannot know, it's just not reported, so then choosing, like beating all the baselines becomes a very trivial problem, right? Because the ranking of the baselines and of ours, in the end, it depends, it can be random, because some hyperparameters taken from original papers that use entirely different data sets, some maybe just default parameters, which we found on the final GitHub version, and some parameters are chosen arbitrarily, I would say, for fair comparison. And we found cases where authors might have just not even run the baseline code, but just copied the numbers from the previous papers, even so the evaluation procedure might be different, the pre-processing might have been different, so that's very, very worrying. And the consequences of all this is every model can be a winner. And to showcase that this is the fact, we did some simple experiment, which took weeks, of course, to compute. So we benchmarked 8 deep learning models, which any reviewer would agree, now this is state of the art, that's good effort, 8 neural models, that's good, huge effort. We tuned all of them, given the limitation of resources we had, and then we compared each tuned model against all non-tuned, like randomly parameterized models, and the outcome is even the worst of the tuned models is better than all the baseline models, right? So in such a comparison, if we follow what seems to be a standard methodological approach in our field, everyone can win. So, and this might really limit our progress, and that's a problem. So here's the result. You can look it up in the paper, just the 8 models, and in all metrics, on all data sets, every method beats all the other baselines in some ways, right? So everyone could be ours in boldface, significantly, by the way, if you measure correctly. Good. And by the way, when we used this experiment, we used a protocol from another paper that did some systematic analysis, same data sets and procedures. But there's a little secret. We left out one of the models that was there in the original evaluation. This is the, so let's say, shallow model, EASE-R by Harald Steck. And this one, in our comparison, would have had the best values, mostly, would have outperformed all of them. It is only on one relevant hyperparameter, and even that is it doesn't matter much. So, And this again brings us to another problem, a related problem. We have there's some arbitrariness of what we include as baselines. So nobody would challenge us saying, okay, 8 deep learning models from 2021 to 2023, that's fine, right? Now, but we intentionally left out this other, it's not a deep learning model, not state of the art, it's not complex, so that's another problem here. So, and the sad thing or depressing thing in some ways is this is actually very well known. You cannot read the references, but they're on the paper. So we know that this is a standard problem in applied machine learning research, not only in recommender systems, it's information retrieval, it's time series forecasting. They all share the same problem, or many other fields, right? And here's another blog post from some frustrated ML person who even said it's a day-to-day fraud, which is a bit of a drastic thing, saying, okay, what we do in this sort of mini fraud is we tried a new algorithm on a couple dozen seeds, report the best few, we run a big hyperparameter sweep on our model, but take random things there, and cherry pick examples or entire data sets, right? I wouldn't go that far, but this seems to be a pattern that others have observed here. So what are the reasons? We still know there's 0 insights we can get from this comparison, as we see from the example. Why is it still common? Yeah, because, I don't know. For example, the baselines, implementing all of them in a common framework, which you have to do, like integrate them, all of them to make the exact same measurement is tedious. The tuning can take weeks for each individual model, and maybe some ideas just don't work at all. So you have this confirmation bias that you try to have your shiny new ideas working, right? But the last thing I think is the most important one. It's the accepted standard. You're not going to be rejected, as we see from the analysis of top-level conferences, if you do this shallow reporting. We don't know what's done in the background, but it's not reported. What can we do? So many things. One has to do maybe with the publication culture, the incentive system that we have in the academic thing. We're pressured to publish quickly. We don't have time to do everything that needs a lot of time. One other thing is maybe we should go away from all this leaderboard chasing at all, which relieves us a bit from this problem. If you're just having 5% every paper and 100 papers per year, gives you a lot of improvement over the years maybe. Another aspect we should work on is raising awareness about the problem, which we try with this paper. We try to educate and train all stakeholders. If you look at textbooks, there's a lot about evaluation, but not much about tuning and proper methodology. Reviewers should be trained, students should be trained, professors need to be trained. And finally, we should also try to just improve our standards. And there are various proposals in the literature for how to do fair comparisons. Reproducibility is a cornerstone, so in the best case, you publish everything. Your model, the baseline code, your evaluation code, pre-processing code, everything you need to get to the numbers that you ultimately report in the paper. And one last thing is that you should use, if possible, use evaluation frameworks that are out there, not re-implement everything, make the same mistakes others have made, but use frameworks that are there, make sure they're validated. There might be some problems there, but they can be fixed. But then it helps us make things much more reproducible, and hopefully we can have more progress than we have so far. So this already ends my talk. Congratulations to everyone who was a winner this year, and happy to take your questions.
Thank you, Dietmar. You can ask questions on Slido or enter the microphone. Are you ready there to ask a question? Then go ahead.
Hello. Thank you very much for your presentation. Interesting problems raised. Can you go a little bit more in the selection criteria of the papers included in the study?
I think we manually selected a set of conferences based on research experience. So I think people would agree are top outlets and have A or A star ranking in the core Australian system. And I think for this study, we looked at papers that addressed the top end ranking problem. So not sequential, but these ones. And there were some other criteria probably which might be in the paper. Okay.
Okay, Joe?
Yeah, so I want to pose one more reason this happens that was not on your slide, which is the sunk cost problem. Our model involves evaluating research after it's done, rather than evaluating the plan for research before you put all the time into it. And if we wanted to be serious about some of these things, what we might want to do, and somebody who edits a journal could think about this as a creative way to change things, hint, hint, is allow people to submit the plan before they do the work and have reviewers come back and say, yes, but if you're going to do this, you need to do it this way. You probably need to change certain things, so that at the end of it, we actually had confidence in the results rather than scrambling to figure out where we can, publish whatever we came up with, because that's what we worked on the last 6 months.
Yeah, thank you very much for this suggestion. Indeed, this sounds a bit staged, and we do have for the journal ACM transactions and recommender system, we have the category of registered reports, which seem to be going to that direction, which are not commonly used yet or by our authors. But thank you again.
Okay, wow, things popping up on Slido a lot. Which one did I take? What about the fact that sometimes reviewers ask you to put a model into the baseline list, and this model does not provide the code or a way to reproduce?
Can you repeat that? What about?
What about the fact that sometimes the reviewers ask you to put the model into the baseline list, and this model does not provide the code or a way to reproduce it accordingly?
This is certainly a problem. First, that this question is asked by the reviewer, maybe. They should know if it's there. But if there is a good reviewing culture, there should be a way to respond to this reviewer explaining the problem, right? Because I think from the descriptions in the papers, it's usually not easily possible to come up with something that's exactly what is implemented by the authors. So.
Okay, thank you. You have a question? There's time for one question.
Hi, yeah, thanks for your talk. Wow. So I come to machine learning from a different scientific field, and one thing that stands out to me is that one thing that would help, this is maybe more of a comment than a question, but if you have some, rather than just reporting, we tried these 5 different models and this thing did the best, some underlying theory or explanation about why one should expect that this is actually the best rather than just the sort of phenomenological report, and maybe they should spur more research into why certain models are more successful than others, and I think that would be generally more enlightening anyway.
Yeah, I entirely agree, and I would extend this should apply also to the proposed model, because the motivation for the proposed model as well is not based on any theory often, in my experience. Thanks.
Thanks a lot. There were lots of more questions on Slido, so you should better go to Slido and answer them. Big hands for Dietmar again. Thank you.